Hi, my name is Alex Thompson. I'm a product manager at Fluke, and today we're going to be walking through how to use our new FEV500 Fast DC EV Charging Station Analyzer. So we just turned on the FEV500. This is the home screen, so the first screen that you're going to see when you turn on the device. Over here in the right-hand corner, we have the settings menu. So this has language, date and time, and product info as well. So this is where you can check to see what firmware revision you have on the device, product registration, and calibration info. So we're going to go ahead and set up a new project. Any project that we've already tested that is still on the device will be showing on this screen. So you can see earlier we had a different inspection over here. So we are able to click on that to see past test results. But in this case, we're going to go ahead and go through setting up a totally new project. So I'm going to click New Project. From here, you have the option to select or create a client and site. So any previous clients that we have are going to be listed here, or I can choose to add a new client. For this, I'm just going to say XYZ. And I should be able to click Done. And then for site, I can do the same. And then I'm going to click Next. Now that my project and client and site have been added and the project has been created, I'm going to add a new charging station. Here I have the option to add in the manufacturer and model info and the date commissioned from the charging station. So here we are working with a Delta station. And for model, I'm going to say it is 100 kW. Date commissioned, since I don't know when this charging station is commissioned, I'm just going to put in a random date here. But you also have the option to skip this portion of the project setup if you don't have this information or it's not important for your particular workflow or inspection. And now we're going to click Next. This, what you're seeing on the screen, is a unique identifier that the FEV500 automatically assigns to the station. You do have the option to delete this and put in the station serial number, or your own company identifier that you use to ID your stations. But I'm just gonna leave this like that. Now you can see we're getting into the actual inspection. So it's now prompting me to insert the connection point over to the CCS1 connector over on the right-hand side. Now you can see we've connected the CCS1 connector into the socket. It's establishing communications. When I connected it, I also was prompted from the actual charging station to swipe my RFID or credit card for payment, so that has also already been done. Perfect. So we got to check that communication was established. What you're seeing on the screen, so the first value up here is slack attenuation. So that's going to be a measurement in decibels. Ideally, you want your measurement to be between 0 and 10 dB or decibels. Essentially what that's doing is it's an attenuation signal that allows the charger and vehicle to identify each other to begin communicating. You can see on the right-hand side, this is where low-level communication or control pilot states are listed. Later on, you'll see that we'll have the low level as well as the digital or CCS charging states. After the charging station has been connected, like you're seeing here, we're also going to see the voltage rating and current rating that's automatically pulled off of the charging station when it communicates to the FEV500. And then lastly here, we have our EVSE ID. What that is a unique ID that you can put for your charge point or connector. So if a charging station has multiple connection points, you can identify which one you have tested. So here I'm gonna just put CP1. Now I'm gonna go ahead and press next. And now this brings us to our continuity measurement. This is optional. This is kind of the last test before we get into the auto test format. So you do have the option to skip this measurement, but I'm gonna go ahead and walk through it. The continuity measurement, it's basically what we're going to do is use a test probe or remote test probe that comes with the unit. It has a little test button up here. So we're going to use this to connect to the different metal parts of the housing of the charging station to measure for continuity. So the first thing I'm going to do is zero out my test probe or null the test probe to make sure that our measurement is going to be accurate. So I'm going to select 0 over here, and it's asking that I connect the test probe to the R-low input jack, and then the tip of the test probe will go into the sense 0 input, so I can essentially null or zero out my test probe. So once that's inserted, I'm going to press the test button and hold that for a little over 5 seconds on the remote test probe until I see my measurement pop up here. You can see we see 37 milliohms, so I'm going to accept that offer. Once you accept your zero offset measurement, you can really use that throughout the duration of your inspection. So say you have 10 different charging stations to inspect on a site, you don't necessarily have to zero out your test lead every time. Okay, now that we have zeroed out our test lead, I'm going to connect the test probe to the different metal housing points of the charging station to take my continuity measurements. Okay, now that I have taken my continuity measurements, and you can see you're able to take multiple measurements, up to 10 test points can be added. I'm going to press next. And now it's testing the insulation resistance. So running an insulation test on the output of the charging station. And you can see here we're testing between DC positive and PE, or protective earth, and DC negative to PE. Perfect, and you can see we got an individual pass indication on the DC positive and DC negative measurement, and then an overall pass. So you will see all of your pass and fail measurements, or indicators on each measurement, rather. Okay, next I'm going to hit connect. One call out here, something to be mindful of, you'll want to pay attention to what the actual charging station is communicating to you on screen. So this, the charging station, the FEV500, aren't actually connected when we're doing the insulation resistance measurement. So now it's essentially going to reestablish communications. This oftentimes will mean you need to re-authenticate or swipe your RFID card or credit card, or use your, if you have some kind of a mobile app for payment. And occasionally, depending on the charging station, some of the charging stations also like you to disconnect the CCS connector from the socket on the FEV500. So just, again, be mindful of what the charging station is saying on the actual UI or screen display, so you know exactly what it wants you to do. So I'm going to press connect. And I just authorized the payment on the charging station. So now we are getting into the load test. So you can see you're going to have your voltage, current, and power in terms of the voltage test measurements. And then over on the right-hand side, you can see that it's showing, again, the low-level communication states or control pilot states, as well as the CCS state. So we're now in the initialized state. So now we're going through the load test. So you can see over on the right-hand side, all of the digital communication or charging states, the CCS charging states. So we're going through cable check, pre-charge, and of course into charge now that it's doing the load test. You can see our live results are coming in for voltage, current, and power. And then once it finishes the load test, we should have our pass-fail indications and move on to the next measurement. Now we have the IMD test. So IMD, that stands for Installation Monitoring Device. Similar to like a GFCI that you would see on a level 2 station, this is also a protective device that's installed in the fast DC charging stations. I will call out a lot of the older infrastructure does not have an IMD, so if that's the case, you might see the trip test show up as a failure, which we're seeing in this instance. So what was happening there, we were performing a no trip and a trip test essentially. And because we didn't have an IMD test, it showed, yes, it passed on the no trip test because nothing was tripping. But since it didn't have the IMD, we weren't able to trip anything, which was showing a failure on the trip test. And then the last measurement that happens kind of simultaneously with the IMD trip test is a residual voltage test. And I'll talk about that in just a second here. So now that we've run through all of our measurements and our inspections, you're seeing all of the results listed out here with a pass-fail indication. Up at the top, you can see the test ID. So because we've run the test 2 times on the charging station, we'll have test ID 1, which we can go back to, and then test ID 2. And then from here, I'm able to select any of these measurements. It'll bring me directly to the more detailed view, and from there, I can just scroll on the touch screen to view all the measurements. So yeah, here we're seeing the failed IMD trip test because we didn't have an IMD. And then the last test is the residual voltage test that I was mentioning. Essentially, this is like a discharge voltage test, just making sure that once the charging session has been complete, that voltage is at a low enough safe level within a certain amount of time. And after you view all of your measurements on the screen, the FEV500 does have a USB-C port, so you can pull off either with a USB stick or a cable and download all of your measurement results into our TrueTest software. From there, you're able to customize reports, generate PDFs, or export to CSV. And that's how you use the FEV500. Thanks for watching.